Alright, in this third video of Molarity, I'm going to again show you how to make a solution. I got two different examples here, but as a review, remember Molarity. Molarity is Molarity. Okay, and as you can see here, the word moles are in there, and that's there for a reason. We short molarity to a big capital N. I'm just going to write it right here in our triangle. Molarity is defined as how many moles of solute are in a liter of solution, or some volume of solution. But before we get to the actual problems, I wanted to show you an example of this at play. This is Steve Spangler on the Ellen Show.
That you like magic. I actually grew up in a family of magicians, and so I brought you a chemical magic trick that my dad kind of perfected years ago. And so, so here you go. Hang onto the beaker,
okay?
And hang onto this beaker. Two colorless liquids.
Okay.
So what I want you to do is this: you're going to pour this one into. No, don't drink it. Pour this one into this one, and then pour it back again, and then we're going to concentrate.
Okay.
So pour it all in.
Pour
nice
it there.
job. Keep going. Now pour it back.
Okay.
Good job. Good. Nice job. Now maybe one more pour.
Okay.
Yeah, one more pour. And I just want you to hold it and concentrate. Ready? Think ink. Think about ink. Keep thinking. Think some more. This is the part of the program where you say, oh, I hope it works. Oh, isn't that awesome? It's like magic in your hands. Wow.
Wow. So fast all at once.
Like that.
That is a very classic chemical reaction called the iodine clock reaction. If you really want to see it done all sorts of different ways, just YouTube search actual reaction. I'll show you another one of it here in a minute. But how do you make that? It does involve starch. I'm not going to show you anything how to do that. But it does involve this substance here called sodium bisulfite, which is that. And it does involve something called potassium iodate, which is over here. Basically, what you do is you need a liter of each solution, and then you dilute it down to get different effects of the actual reaction. But I have to make this. Okay, I need a liter of sodium bisulfite, and I need it at that concentration. All right, so I go in the chemical closet and I get that bottle, and then I figure out, okay, how much of this stuff do I actually have to mass out? This is exactly what you're going to be doing in the lab yourself over the next couple of days in class. So this is another reason I wanted to show you this video. If you know the volume of solution that you're going to need, and you know the concentration that you need it at, all you have to do, figure out the molar mass, and then go from there, right? But when we look at our molarity triangle, we see that if we know our concentration or our molarity, same thing, and we know our volume, we can figure out moles. So let's just do that first. Let's do this one on the left. All right, let's pick a different color here. Do some blue. So we have a 0.25 molar solution of sodium bisulfite. We're going to multiply that by our volume, which is 1 liter. Very easy math. When you need a liter of solution, we need 1/4 of a mole of sodium bisulfite. Okay? So, to go from moles to grams, simply multiply by the molar mass of the formula that you need. And so we're going to go 0.25 moles times the molar mass of sodium bisulfite, which is what we're going to figure out right now. All right, so we're going to go down to our periodic table. We're going to go back to web elements. All right, sodium bisulfite. We need a sodium, which is over here, 22.99. 22.99 plus a hydrogen, which is 1.008, plus a sulfur, which is 32.06, 32.06, plus 3 oxygens, and each oxygen is 16. So 16 plus 16 plus 16, that equals 104.058. 104.058. grams. We need a quarter of that, okay? And so we're going to multiply that molar mass by 0.25. So back to our calculator, that number times 0.25, and we need 26 points, what is that, about 26.01? All right, I would, on our balances, actually just put 26 grams of that onto a balance. All right, so that's figuring out, okay, if you need a quarter mole solution of sodium bisulfite, you need a liter of it, that's how much you would put into a liter. If you need 500 milliliters of this concentration, you would just put half of that. All right, so now we're going to figure out for the other solute here, potassium iodate. Again, a liter of 0.1 molar potassium iodate. Math is very similar. Molarity times liters will get you moles. So the step one, I'll actually write the steps out this time. Calculate, I'll shorten that to calc, moles. Moles, just like we showed in class, is molarity times liters. Our molarity is 0.1 molar. Our volume is 1 liter, so we need 0.1 moles of this potassium compound. All right, step 2 is calculate grams by multiplying by the molar mass. Whoops, multiplying by the molar mass. Alright, so basically what we're going to do, we're going to take our 0.1 moles. I already calculated the molar mass of potassium iodate. Basically what you would do, you would take a potassium plus an iodine plus 3 oxygens. Try that out on your own using the periodic table you either have, or you can go over here to Web Elements and you can add up the masses there. And it is 213.998. I'm going to round that to 214. It's pretty close to that. 214 grams per mole. And when I write it like this, you can actually see why you're multiplying by the molar mass instead of dividing. We have to cancel out moles here. All right. If we divide by the molar mass, we won't be able to cancel out moles, and we're left with the wrong unit. All right, so 214 times 0.1, actually pretty easy math, but we'll show you here anyway. 214 times 0.1 is 21.4 equals 21.4 grams. That's how much you would put on the balance. Mix it with a liter of water. You would need this one on a balance, mix with a liter of water, and there's a couple other things, ratios and things to make this reaction go. You would mix some, dilute these down with some water a little bit, add some starch in there, and it's the reaction between these two with the starch that's going to create that iodine color. Another real fun thing that you can do with this, if I actually got the solutions to work in class today, you would have seen it done this way, and I'm going to show you another one. If you have questions on how to figure out how much or grams from a concentration and a volume, just come up to ask. If the videos aren't working for you, there's going to be lots more practice in class as well that we're going to do in the lab. One more look at this, kind of a fun way of doing this. We did this last year, kind of a neat way of That's the another variation of the iodine clock. Again, just diluting these solutions way down to a much lower concentration just makes them slow way down. I mean, that just makes sense. If you decrease the concentration, you slow a reaction down. That brings back some information from last semester, actually. All right, so there you go. There's video number 3 on molarity. Molarity again is moles divided by liters. If you have to find grams, multiply your molarity times liters to give you your moles, and then convert from moles to grams. Right here, step 2, by multiplying by the molar mass of your formula. There you go.